Hello everyone, I'm Philip and I want to show you something about our ProLevel system. The ProLevel system contains a T430 self-leveling sweep laser and our R260 laser receiver. Both components are mandatory for measuring leveling and/or flatness tasks. So let's start to have a closer look at our T430 self-leveling sweep laser. The T stands for transmitter and the R of the R260 receiver is for the receiver. So just that you know, T transmitter, R receiver. In the T430, we have a little button to open the battery cover. We press it once and then we can remove it and now we see the battery. The battery is the same as in many other components from Status Pro, so you can use it in our digital spirit level, in the laser receivers, and of course in the self-leveling laser. So we just insert it back again, close the cover, and then the laser is ready to work. Using of our T430 self-leveling laser is quite easy. It has two buttons. The first one starts the laser. So now we press the button and the laser already emits a laser beam. In this case, we do have the T430 here. We have two laser beams. One on the side, which will create the laser plane, which we will need later, and one on the top. This is special because this is a T430. There is also a T410 laser from Status Pro, which does only have one laser beam. So there is no laser beam on top. For leveling on flatness tasks, you only need one laser beam. So in the ProLevel 50 system, you will get a T410 laser, and in the ProLevel 100 laser, in the ProLevel 100 system, you will get a T430 laser. Okay, with the second button, we can now activate rotation. So now the prism inside of the laser started rotating and creates a laser plane for us. So this laser plane is now our reference for the following measurement tasks. What makes the laser so special is that inside of the laser there are two motors which can control the position of the prism in relation to the gravitational field of the Earth. So if I activate now the self-leveling mode by just pressing the green button once again, we can see that these LEDs start to blink. And this signalizes to me that the laser levels itself. So the laser plane, which goes round and round this laser, is now leveled. So to say it in other words, the laser plane now would be parallel to the water surface of a lake or to the horizon. That's how you can imagine it. We can use this now for very precise leveling tasks. We use now the R260 laser receiver for that. The R260 laser receiver has a 50mm laser detector in front of it, which detects the position of the laser beam. The R260 laser receiver has the same battery as the T430 laser. By just opening this cover, we can put it out and we see it's the same battery. Usually we say something like 1 or 2 hours charging will give you something like 6 till 8 hours of operating time. So we will just put it back on our editor. And we are ready to go. We will start it by pressing the first button. We have another video where we show all of these buttons in a very detailed way with all of its functionalities. In this case, we will just start it and we will get a measurement value at once. So we can see here the measurement value. This value does not give us lots of information right now because there is no reference for it. So when it comes to leveling tasks, we usually start by making it 0 at a specific position. In this case, maybe we can start just here, which we will show you a little bit more detailed in the next video. Let's have a closer look at how to level an object now with our ProLevel equipment. So the laser is already leveled. We can see this because the LEDs are flashing. As a matter of fact, we would even be more precise if they would be permanently green. But this is not possible on this wooden table here in our meeting room, because the laser checks constantly for vibration, and if he determines some vibrations, then he will show us this by signalizing it with the LEDs that they are blinking. It's not a problem at all, we can still level, but not only that precise as it possibly is with this system, or as we possibly can do it with this system, because we can level down to a few microns per meter, but then of course the LEDs have to be permanently green. For now, this is okay. So on our first position on the table, we will just make an offset by clicking the 0 button. So we zero the receiver. We can now see that the value on the display is 0. We now can immediately move the receiver to another position on our table. It's always mandatory that the receiver looks straight to the laser. So we will move it a little bit, like this. So we have highest accuracy when the laser is aligned roughly to the laser. So now we can see on the display that it says something like minus 1.2 millimeters. Minus means we are lower than on our reference position. So this is how quickly we can level an object. We immediately see the deviation in reference to our first position. And due to the fact that this value is live, we could even align right now. If I just lift the receiver a little bit with my hands, we can see that the value changes to a positive value. So that's how easy we could align this position right now. So just imagine you have a big machine bed or something like that, and you have these movable machine feet. You can just adjust with your tool the height of your machine to the 0 position where you want to have it. Let's check the second axis by moving it to another position. Here we can see that the table is leveled even less in this direction. Here we see a value of roughly minus 5 millimeters, which is not a problem for a wooden table like this, but might be a problem for a precise machine. And of course, we are not limited to the positions. We can put the receiver wherever we want to, and we will get immediately a value and see how leveled or misleveled our object is. So we just talked about leveling, but now we want to have a closer look about flatness. What's the difference about these two things? So when an object is perfectly leveled, it usually is flat as well. But let's imagine this table. We could lean it on the wall and it could still be flat. So this is the difference between leveling and flatness. Leveling has always a reference to gravitational field of the Earth. Flatness is just looking at the object itself. So now we can level the laser again, but then we would not see how flat the table is. So that's why we will continue by aligning the laser plane to our measurement object, in this case the table. We do this again, of course, by using the laser and the receiver, and additionally our laser tool software. In the laser tool software we can see that our components are already connected. We can see that here both of these symbols are shining, and we will move now the receiver close to the laser. We will zero it. We could either press 0 in the software or we make a 0 on the receiver. The advantage when making a 0 on the receiver is that you have the 0 in the software and on the display of the receiver. If you zero the software, it's only an offset inside of the software. Okay, so we made a 0, and we will move the receiver to one edge of the table. We can see now a measurement value of something like minus 2 millimeters. This does not really give us any information because laser is not already aligned. So we will align it now. Good thing is about our equipment, it can be aligned by itself. We just have to activate the Control X button. So why is it Control X? Because I'm checking the laser ceiling right now, and I can see that it's the X-axis. There is also a Y-axis in the laser, like this, and an X-axis. So we right now need the x-axis. So we will deactivate it again and we will recheck, because we have to check this a few times, because at the closest position we are not really in the center of rotation. So we will zero the receiver again. In the first step we had a misalignment of 2 millimeters. Now it's already only, let's say, roughly 2/10 of a millimeter. So we will align it again. And I would say on this wooden table, let's aim for a few hundredths of a millimeter, and I would say that's it. So it's 0 again. Let's check it at the first position again. More or less 0. So we will continue with the second axis, the y-axis of the laser. We can see that it is something like 2.6 millimeters. So we will act Control Y. So the laser will proceed by doing the alignment in the y-axis. When it is quite quiet, we can even hear the motors in the laser moving, something like bzzz. We just check our value, and when it gets down to more or less the 0, we can deactivate the control and check again. Okay, so at the first position, we will make another 0. So we have 0 on the receiver, 0 in the software. Zero at the second position. And let's check the third position, more or less 0. So now we can be sure that our laser plane is aligned to 3 points of the table. A plane is always determined by exactly 3 points. So the laser plane is now parallel to this 3 points, no matter how leveled the table is. And now we can immediately measure flatness even without software. So we can just put it to the side and only use the display of the receiver itself. And now we can see something like minus 0.3 millimeters, something like that, which is quite normal that the table is a little bit lower in the middle, you know, because the feet are at the side, and in the middle we have a little bit of deformation or something like that due to gravity. So it's quite simple. On every position we can now check flatness of this table or any other object. Of course, it would be possible to connect this receiver to our ProLevel software as well. In the ProLevel software you can create a grid and then measure the information of height for each point in your grid, and then you can evaluate and analyze the information in a very detailed way. You can see this in other videos from us.